Welcome to my tutorial, which will explain how to use Mathematica, which will be a convenient way for you to graph your 3D figures and graph your vectors. So let's get started here. First I want to show you that how to access Mathematica on school computers, and that can be done by clicking the Start menu, going to Programs, and clicking on Mathematics, then clicking on the submenu called Wolfram Mathematica, and then running the program itself by clicking on Wolfram Mathematica 7. Most of the computers in Gladfelter have it. I have not checked all of them, but I've checked 3 rooms just to make sure there is enough computers that have that program. So for sure, room number 201, (203) and 204 have Mathematica installed on them, so you have access to Mathematica 24 hours, 7 days a week. So whenever you have the need to use it, feel free to go to Gladfelter and go to those rooms. Now let's start the program. And at the first glance the program doesn't look that welcoming, and hopefully it will be a little bit more welcoming by the end of this tutorial. And the way I will run this tutorial will be by showing you some examples and trying to explain you how they work. So I will pull out some code, and I will start with the simplest graph, which is the 2D graph that has 2 points and line passing through them. So this is parametric equation for x and y of x and y coordinates of the points, and t ranges from can be either -1 or 2. Now this part specifies the color of the line, so that's it for the code, and once you run it you have a very beautiful graph of the line. Now you will probably not use such simple graphs in your project, but you can use this idea to pretty much not graph any points and make it uniform coordinate system and draw some stuff on it. So I'll show you how you can do this. So let's delete the old graph and let's grab the new one. Now we have a plane coordinate system, and in this coordinate system you can draw some vectors, and in order to draw some vectors you need to go to the graphics tab and click on drawing tools. Now once you are here, it's very easy to draw vectors. Let's suppose I want to draw a vector from the origin, and let it be this. Now I want to name my vector. I will name it W, and let's say there is another vector going, and I will name it U. And now I will move to more advanced stuff, which will be 3D drawings. So close this window and I'll move on. So the simplest 3D plot would be in this form, where this is z equation. You can imagine as this being equal to z, and this is basically the range of x, and this is the range of y. Now if you graph this, you get you basically get this, and you can rotate this figure, which is pretty cool. but that's not what we want to put in our projects. We probably want to add some more cool stuff to it so it looks a little bit better. So I will show you a code that has another parameter added to it, and I'll show you how it affects. So right now there is another parameter called box ratios, which basically is the ratio between the x side, y side, and z side. I will run the code with like the different ratios just so you see how it looks like. So you can kind of see that this is the x-axis, which has 2, this has 4, and this is 6. Now, if we don't really want such ratios in our project, so I will just try to stick with ratio of 1, 1, 1. This is the most symmetrical one and has the most pleasant final result. So this looks good, but let's try to improve the axis. Now, to improve the axis, I will pull up some more code. And this code looks like this and has the old box ratios that I just explained, but has another functionality, and this functionality basically tells the function which sides of this box can have axes on, and basically this is expression to have the axis on x and y and z, and this names the following axis to be x, y, and z, because you don't really have a name for the axis, it's kind of blank. And what I will do, I will actually turn off the box, so whichever sides are not used will disappear. So let's grab this and see what happens. So that's what we get, and that's what we expected to get. Now since this is a very good result, you might want to consider saving it. So I will show you how to easily save your results in Mathematica. It's very easy actually. You just right click on the figure and you just click on save graphics as, and you pick a name. I'll pick a name to be a figure 1, and I will save it as JPEG. Once I do that, I can go to my desktop and see the figure. Now I will show you one more example where I will actually use different coordinate system, and this will be a spherical coordinate system. And probably most of you remember that this system was dependent on theta and phi. So here is the equation in terms of theta and phi. Here is the range of theta, and here is the range of phi. Now if we go on and graph this, we get a row figure, and we could of course add another functions as we did in previous ones to make it look like this one, but we will not repeat it since you can do it on your own. And I will stop here, and hopefully that served you a nice light introduction to Mathematica. And now I will show you the greatest resource ever for Mathematica, which can be accessed by running any web browser and going to google.com. Basically, this website is your answer for everything. If you wanna know how to graph 3D figures, you just type in 3D figures Mathematica, and you will see some documentation on it explaining you different functions. You will have some posts, some tutorials, so you should definitely try to use Google if you are looking for some help. However, if that doesn't work for you, feel free to email me. This is my email address, so feel free to send me questions or concerns or comments. Thank you for your attention.